The second video of the Antonus stepbrother build. The first one was just a time lapse of me soldering all the parts, and this one is in this one I'll show you how to put in the power supply and how to adjust everything and fully calibrate the sequencer part and the extract part. So yeah, I hope it helps. Enjoy. There's just one more correction I need to do before we can move on, and it's in the file folder, which you can download from the Antonus website. If you go to corrections, there's actually a little botch wire to correct the step 1 gate out, which I think it's skipping or something, I'm not sure, but we're going to do it anyway. So this is the 1.5 version of the board, which I have here. Maybe this will be corrected in future updates on the board, so you could check if there is a connection between those. If there is, you don't have to connect the wire. So let me set down the camera and I'll show you. I'm gonna flip the panel first. So what you could do to check if there already is a connection or not. If you have the 1.5 or earlier, there's no connection. Just measure between those points and there's no connection. So we have to solder a wire between those. So you can connect the wire to pin 8 or 9, they are connected, as you can see. So I'm just gonna use pin 8. Just gonna apply a little bit of solder on there. Like that. We're gonna cut a little wire from here to there. Apply some tin on the wires. Gonna cut them off a little short, just to make it a little bit neater. So the first one goes here on the leg of the first fader. And the second one goes on the pin 8 or 9 or both of Z12, like that. So there you go. Let me show you up close. Pin 1 of the fader to one of these pins of Z12. So same thing here. Pin 1 on the fader, and I've got it on focus pin 8 of C12. Alright, so that's the wire. Now I'm gonna finish the case first with the back panel and the power supply. and the regulator board. So I'm going to put this board in the lid so I can take it off and just set it aside without damaging it. Damaging. Just wanted to show you the difference between the stepbrother Meanwell board and the 2600 Meanwell board, because the bottom PCB where the Meanwells are mounted on is exactly the same as a 2600, but in the 2600 you connect the mains to the red board, and then that goes to a switch and a fuse, and that goes to the Meanwells. But on the stepbrother, this is the back panel, you can see there's already a switch and a fuse on there, and these main wires, these go through the switch and the mains and the fuse. Those go directly on one of the Meanwells, so you don't have to use any of this. You can forget that, so to speak. You can forget about this part. This is just, you can cut it off. So this goes directly on there, but I'll show you, of course. I'm going to start with the back panel, which goes over there. So that's this one. This is the back panel, which has the power inlet on it with the fuse and the switch, mini out through, etc, etc. So you can, this is the MIDI through cable. That one actually goes over here. You can connect those already, like that. This is the other one, MIDI in. This is the foot switch, but that goes to the main board. And here's your power inlet to the Meanwell supplies. So let me set up the camera and I'll show you how to mount this. So the back panel sits right over here with the power inlet in the middle of the case, not on the side, and it's attached with 10 screws around, which are provided, of course. They come in these plastic bags for which my hearing is really allergic. My hearing is really allergic to this plastic. So let's put it like that. Let's screw the back panel in. Oops. All screwed up in a good way. The bottom screws are a little bit hard to get in, so I use this screwdriver with a rotating back, and I'll just show you if you hold it like that with your palm against the case. You can push with your thumb and turn with your other hand. That's how I did it. So it's now fully in place. That's how it looks from the back. Really cool. So, next up is the power supply section. So the Meanwell board just already has like some nut standoffs. You can just screw that right in place. And the regulator board, which I'm still not sure if I'm using, if these heat sinks are capable enough to reject the heat, but I'm going to check that later on. Now that needs some standoffs, which are also in the kit. And just put the regulator board on top of that. Like so. Let's get a different bit. And screw them in. So I had bigger ones, bigger heat sinks, but they were actually too big because they were too tall, so they hit the main board when I put the front with the board in. That's why I opted for these, which I had lying around. Now this cable going directly to the regulator board. So you can slot that in. And that's that. We're going to strip these wires and screw them on one of the inlets of the Meanwells. So let's do that. First one, just match the colors and you'll be fine. Like that. And the third one. Like that. Check if everything is fixed. Put the cap back on. And that's that. So these regulator boards are actually turned all the way down, which is enough. I think it's supplying around 21 volts plus and minus. That's enough to make a plus and minus 15 volts on the regulator board to the main board. But we're gonna check it, of course. So before powering anything up, let's check the regulator board if there's a short. Just to be safe, nothing blows up when we apply power. So let's check the plus rail to ground. That's fine. Let's check the minus rail. Also fine. So now we can flip the switch. Everything good. I can show you these Meanwells are set to about 21 volts, 20.26. So that's with the trim pots all the way down, and that's enough to supply the regulator board. So now we can trim the plus and minus rail. So one probe to ground and the other to the plus test point. 15.14. Let's adjust this trim pod. To 15 volts. That's one. Now onto the minus side. Nope. Which is the left trimmer. I can get my little trim tool on there. Yes. Right there. Check the plus again, just to make sure, and the minus. Beautiful. So, the regulator board trimmed. I'm going to show you how to check your main board to see if there's no short on the power rails. So hang on. So on your main board there's J25, which is your power connector from the regulator board, and there's a test point ground minus and plus 15, and I always like to check between ground and the rails, so minus 15 to see if there's a short, and there's not. Plus 15, no short, so that should be fine to connect. And yeah, let's do that. First we have to make some connections. So there's a power header over here which goes to supply power to the board on the back panel. So that's this wire. Let's do that. So one goes in here, and the other side of that goes in there. There. And then this is your foot switch, which goes into the main board. And here we have a cable for the MIDI clock. That goes right in there. Also to the main board. So I'm going to connect all the cables into the main board. So I just like to put it like that. And flip it over into the lid, so you can just make your connections. I hope this is long enough. Yes, it is. And you can trim it like that. I think, well, that's the way I'm gonna do it. So you have to see for yourself if you like it that way. So that goes. Let's rewire that. Something like that. Let's plug in the foot switch. That goes over here. And the MIDI clock, which goes over here. And then plug in the power. Like so. Oh, to be careful to slide it out. Let's first check if it works. This is the first time I'm applying power to this board, so flip the switch and hope everything is okay. Looks random. So that is scrolling along nicely. Oh yes. Well, that works. Further steps. Ensure the reset. Start. Nice. I'm going to connect a little power extension cord with a knob with a switch on it, so I can switch it on and off remotely, because there's no way, if this is in the lid, I'm going to flip it forward, so I cannot reach the power switch anymore. Now we're going to calibrate the whole thing. So I've got my trusty little scope here, and here is the calibration sheet from Antonus, which is this one for the oscillator and the extra stuff, and this is from the original ARP sequencer service manual. Just wanted to show you how I've put the Temco on the dual transistor with some heat compound, which is right there. So that's how I did it. Isolated the leads so they don't touch the can, which is metal. Decided to do it just a little bit different because you still need access to the controls on the front. So I made this little steel wire hook thingy so I can just flip it up and put it like that. And now I can just trim anything I need to do. So for the first wave shape converter setting, we have to set dial some things on the front panel. So the frequency of the oscillator has to go to 0, the pulse width to the center, and the range switch in high. For the second part, we have to connect the output of the sawtooth into our oscilloscope to adjust it. So I've made this little cable so I can plug in the sawtooth output directly into my oscilloscope. So when I plug the sawtooth output into my scope, I just got absolutely nothing. Turned out the whole oscillator wasn't working, and there was a little voltage regulator which was broken. So I botched in a bigger one. Not pretty, but it works. And I'm now getting a little sawtooth. So now we can proceed with trimming the pots. First we're going to set the ramp gain, which is R394, which is this one. And we turn that to get a 10 volt peak to peak sawtooth on the scope. So let me show that. So we're currently at 2.7, which is a little low. So let's turn that trim pot until we get a 10 volt peak to peak. Like that. Now you can see that it's a little bit offset from 0, and we want to see a plus and minus 5 volts. You can adjust that with R405, which is this one. Don't think my scope is up for this. I'm gonna leave it like that. So next up, we've plugged into the sine output, and we're going to shape the two halves equally. First we're going to balance the sine wave, so we can do that by watching the minimum and the maximum with R375, which is this one. So you can see you can balance the sine wave, so to speak. Like that. Then we're going to shape it to a sine wave with R406, which is this one. Like that. And that's your sine wave. Checking if all the waveforms are working. So there's your sine, there's your SOT, and it should be a square. Yes, with adjustable pulse width. Very nice. Before we can tackle the VCO tracking, we have to trim or set up the whole sequencer part first. So first we're going to the old ARP service manual and do those, and then we can trim the VCO. Going to calibrate the sequencer and quantizer. To do that, we begin by calibrating the frequency of the clock. So you do that by setting the clock to full and the rest all the way down. So we're just doing the sequencer and quantizer part, which is the original ARP section, and this section has been added by Antonus. So you've got an extra envelope generator and high and a low oscillator and two VCAs, which you can patch things, so that's cool. So with the sliders all set, I'm going to put it up again, apply some power. So now it's running. If it's not running, you have to press the start button. So now it's running. I forgot to put the clock output into my scope, like so. And now we have to adjust R19 for 100 Hertz. R19 is right next to the power connector. Going to adjust, it's now 82 Hertz. Let me just put it back a little. It's now 82 Hertz. And we are going to set it to 100. It's the wrong way. So at the lowest clock setting, it will put out 100 Hertz. Like so. Now we're going to adjust the pulse width. We have to set up a lot of things to do this. So step number 1 is put all gate assignment switches fully up into the gate bus 1. So these all have to be up, like so. Monitor the clocked gate 1 output. So that's that one. Clocked gate 1 out. Put the gate trigger switch sequence. Put the gate trigger switch trigger mode. That's this one. Trigger mode. Start the sequencer, but we don't have power yet. Put the clock frequency slider fully up. This one. FM slider down. Pulse width fully up. Turn trimmer R26 until waveform disappears. So, the sequence is running. We're seeing something we don't want to see that. So R26 is I don't know. Oh, right over there. If I can get it. We have to turn this counterclockwise until the waveform disappears. Turn no further. Alright. Oop. Well, that's gone. So that was that. Next up is the calibration of the quantized outputs, or the offset of them. To do that, we have to isolate the quantizer inputs. We can do that by plugging in a patch cable into input A and B. So now we can adjust R206, which is this for output A, to a 0 volts, and R207 to 0 volts for the quantized output B. So I'm going to plug both channels into my scope. Output A in the first one and output B in the second one. So we can see on the scope it's minus 2428 millivolts. That has to go to 0. So this is measuring channel A1 or channel A. And the adjuster for that is R206. So let's turn that one. Yes. So let's do the same for channel B. That's 65 millivolts, so R207 is right here. Wrong way. Don't be afraid to really turn on those trimmers. Some of them are way out. Next we're going to set up the quantizer, a CV volt per octave. So put all sliders of the sequencer fully down. Oh, okay. Done. Put the trigger gate switch in the gate mode. Gate. Where am I? Put the sequencer mode switch into the 16x1. It's there. Sequential mode. Alright. First slider fully up. Okay, and then we have to reset it. Let's first put it up again. We're still monitoring the quantized A and B outputs. So press the reset button. When doing that, we are looking for 2 volts on both the quantizer output A and B jack. And you can adjust 2 trimmers for that to get those 2 volts. But when I switch it on, you can see me putting the slider all the way up. And we have 2 volts. And it's exactly the same on channel 2. So I'm not going to adjust those, because why should I? But if they are not 2 volts, you can adjust R266 for the output A and R222, which is this one, for output B to get that 2 volts with slider 1 at the max. So last step of the sequencer part. We have to put all the sliders fully down. Gate mode, which is this one, 16 times 1, and sequential. Press the reset button. Connect the patch cord input A to input B to isolate the quantizer input, like so. Monitor the A sequencer output, which is this one. A sequencer output. Raise the slider to halfway, like so. So we have to write that voltage down. It should be near 5 volts, well it is 4.4. So this one is 4.4. Connect the patch cord from the A sequencer output jack to the CV in jack. So we're gonna take this one out and connect it to the CV input. Okay. And then we have to monitor the quantizer output A, like so. Press the reset button, and that's 4.2, and it should be 4.4, exactly the same as before. So we have to adjust trimmer 217 to 4.4 volts. And then we're going to output the B section and adjust trimmer 218 for exactly that 4.4. Because now this will also be 4.2 nonetheless. So let me set up the camera and I'll show you. So this is quantized output A, and we have to trim 217, which is this one, to the voltage measured before, which was 4.4. That's the wrong way. To 4.4, and then gonna switch it to the other output, like so. And now we have to turn 218, which is this one. Like so, 4.4. Beautiful. Now for the last step, which is the voltage per octave tracking of the internal oscillator. So we have to connect the calibrated quantized output to the CV input of the oscillator, like so. And then set it on the first step by pressing reset and stop. So the oscillator should be in high mode, and we are going to monitor the square output. And then we have to set it with the slider at 0. We have to set the oscillator to show A3, which is 220 Hertz. So let's do that. Can be a little tricky. Close enough. And now, if we set this slider to the middle, it should be 1 octave higher. So it should be an A4, which is 440 Hertz, and it is not. So we have to adjust R376 CV adjust trimmer. So we have a 440 Hertz frequency. Then we go back to 0 and check for the 220. If that is not 220 Hz, we have to adjust 395 and repeat until we get a perfect tracking. So this is 376, which is the CV adjust trimmer, and this is 395, which is the initial frequency trimmer. So we're now looking for a 440 Hz. So we have to adjust 376 for a 440 Hz. And then we set the slider to 0 again. So it now should be 220, and it's not. So now we have to adjust the initial frequency, which is the one next to it, for 220. Now we set it to the middle again. So this should be 440. 376 again. And back to 0. 220. Almost there. Back to the middle. One more time, I think. Just the initial one. Back to 0. I think I'm there already. Just keep doing that till you get a 1 volt tracking. So now this beautiful thing is fully calibrated. We can screw it down in its case, finally. Like that. You get these screws from Antonus. And there it is. One fully built, beautiful Antonus stepbrother sequencer. Let's make a little demo, shall we?